Howdy. I know. Wow, this is the first. You have to forgive my house. You don't have to forgive it, but this is a new camera. Anyway, hi. You have to forgive my headphones. My name is Joshua LaFerriere. These are my birds. You'll have to forgive me on such short notice. I know you wanted a name tag. I don't necessarily have one, but there we go. There's my name. I mean, I have one. I mean, if you really want a name tag, I have one. If you want a fancy one, I'll give you a fancy one. There's my name tag. All right, I'm gonna take these headphones off. So, let's see if we can do this now. GitHub. I've had this project going for, I don't know, about 6 months on GitHub. I had this project in C, and I don't know, I think it was in C Sharp. It was like pulling data from the Federal Reserve, and I found an API that worked inside R, and it was called Fred API R. And the guy that makes it is called JCIZEL. Maybe a woman. I don't know. I guess I'm being biased by assuming it's a guy, but I don't really care, nor know. It's not important. There's basically 3 files, but originally it was just semantic filter, but it's grown into a couple other files. These CSVs are just mistakenly outputted. They're probably not up to date. Regression analysis was where I was doing correlation filtering. No, I'm sorry, I wasn't doing correlation filtering. I was doing cross-validation. I decided to drop that for this project because it was too involved. Because it was a learning process, and I didn't do the partitioning correct. I mean, I did for what I was doing, but I didn't have holdout. So I was overtraining. And then when I realized that, I didn't want to use it for my project. I just wanted to use what you provided, so I didn't mess up. So what you provided is a single pass. So there's no cross-validation. But there is bootstrapping, which I really like. So if I run subsequent passes and I change the seed, in theory, same thing as cross-validation as long as I manually record the numbers. But that's where the for loop would come in. But I just don't have it implemented. But I would like you to know that I did code. If you want to check it out, that's where my cross-validation is going to be at. It's going to be inside regressionanalysis.r. I actually created this yesterday, 574project.r, maybe 2 days ago. Put all your code in there. Started with the homework number 6, multiple regression, I think. Maybe it was homework chapter 6. Multiple regression, and then started augmenting with the prediction methods that you had in the latest R video that you gave us. And then finally today I did the classification. Okay, moving on. My variables start with kind of like a semantic search space, kind of like Google. Fred allows you to pull data frames, but they also allow you to pull categories. So I want to pull entire categories based on these semantic search terms, and these categories just hold like hundreds of data frames. So I'm using those search terms because I thought that they might be related to housing. So 500 would be like S&P 500. I wanted to cast a wide net. So my goal was to grab a large amount of data and try to filter it down quickly. Semantic filter over equals 50 is a floor threshold that I have set. So only grab values that are over 50 or over in popularity. I could change that to reduce how many factors I'm pulling in. Currently, right now, that's pulling in like 237 factors. That's a lot. SPSS would freak out, I'm sure, if you tried to load that many. But I don't know, maybe it wouldn't. I think I have loaded it in SPSS, but good luck trying to automate that. That's the hard thing. That's why R is so useful. But there's no way I could do an exhaustive search space on that. There's no way. Well, I guess there would be if I reduced the number of rows drastically, but that would be kind of pointless. You want rows. You don't want large number of columns. Anyway, moving on. I also added these extra ones. I don't know if they were important. They're probably already included in these. I think I added them because, for hindsight, because I just have it in the code. But I think before I had like a higher semantic score, so they were being excluded, so I would manually add them back in. Okay, CSUSP, whatever. S&P Case-Shiller U.S. National Home Price Index. It's not real price value. It's not nominal. It's just some sort of normalized value on their own scale. I think they based it on year 2000 when they first started, and that was like a base scale of 100, but it's mapped to, all these different cities, and it's mapped to a real value. It's mapped to a nominal value that's converted to a real in somehow, some way. I'm not sure, but I don't really care because I'm measuring the yield. So the yield between that and the yield between the real house is probably very similar. Anyway, I'm using that value. That's the value I get from the Federal Reserve. But then I derive yields for everything. Oh, I didn't know I had that pencil thing like that. Anyway, this is my response variable for the predictor. See that? Predictor response variable. This is my response variable for the classification. That bottom one, the BLY field, is actually based on the Y field. So one's dependent upon the other. Okay, so moving on. Backgrounds. Federal Reserve, I already went over it. Went over the source. Not the source. How long I've been working on that project. The project that I had before was even older. But I've never done all this automated stuff. I only used this project before to do like manual pulling lists and putting it into Excel. Never did it to this extent. I'm really excited to have been able to do so for this class. So semantic filter is like 600 lines of code. It just basically goes in and grabs like 30 years of data by quarter for all that semantic search space I mentioned, and it interpolates. It does some tricky things like some of the data is reported yearly, some of it's reported weekly, some of it's reported daily. So I wanted to interpolate, but then I was having an issue where it would leave like NAs on the tail end, and that's not good because some of the algorithms would like extend the NAs all the way to the end. No, I'm sorry, they would extend the last non-NA value all the way to the end. And that's not good because if you later go in and you detect NAs, you're not going to see it because now that value's filled in. And then if you're deriving yields, then all of a sudden you have a bunch of zeros. Yeah, so you don't want a bunch of zeros in your data. It's going to throw your distributions off. So I had to do interpolation between the end values. So yeah, I was having to do like some real hard thought on this R code. And I did it all in the past 2 weeks, but I took 2 weeks off pretty much. I've only worked the past 4 days in the past 2 weeks doing nothing but project work. I'm using the Reticulate library. It allows me to do source calls to Python. Before I was actually having to write CSVs and SCP the file over to the other Linux Docker container. Now that I mentioned Linux Docker container, this is my, I'm hosting this on Proxmox. If you actually look back here, that is actually like my Intel NUCs that I bought this summer to code on the stock market. Based on the class that I had for the summer. And anyway, I had everything running on my laptop inside VMs, but it was just taking so long. Well, it wasn't taking long, but anytime I'd run analysis, I couldn't use the laptop, so I got frustrated, and so I put it all in those NUCs, and so I put Proxmox on. Why am I talking about this? Is it project related? Yes, I needed this data science station to be able to do this project. To do the ETL project is what I'm getting at. So this is pretty fancy stuff. I don't know of anybody else. I don't know of anybody that could do this in 2 weeks, but I just had a passion for it. Maybe a professor could do it, I'm sure, but I don't know of any students that could do it. Anyway, moving on. Yields.py derives yields based on last quarter, does NA cleanups, does correlation filtering. I do a special 2-pass correlation filtering, but I'll get to that later. And then 574project.r does all like the regression modeling to include classification. Okay, so semantic filter, I talked about all those things. I talked about the output files, kind of shuffles back and forth. I don't need to shuffle files back and forth anymore because I can do the source calls directly. I'm not even using the Jupyter Docker container that I have set up anymore. That's here. I sometimes do the test code, but I'm not actually dependent upon sending CSVs in here and then running the code because I actually do the source call. Here, I'll give you an example. Read. Tell me I'm in semantic filter. Of course I'm not. There it is. See that? Read yields. So if I go here, yields, define, read yields. And then this is like my yields formula. This is actually like the core of it. And then I deal with zeros by just converting the failed division as a 1, as a no yield change. I figure that's the least damaging that I could do with such a variable. And then you see here that 237 factors are produced by this semantic filter dot whatever, and then it goes through the yields, and then derives the yields, does correlation, and then the correlation is done in 2 passes, and what that means is I filter by the upper half of correlations that match to the predictor term. No, I'm sorry, to the response term. And then the second pass I match to the lower half of correlation coefficients of just the predictor terms to try to address collinearity. Unfortunately, I'm still ending up with some variables that are collinear, but we'll talk about that in a second. Input whatever, that's where all the magic happens. And then this is kind of like the actual analysis. So training prediction scores, backstep is the lowest, but I'm just going to beat you to the punch. Backstep just beats everything, period. It's probably because it selects the most factors, but yeah, it beats everything. If you look here, this is best linear. So I even, because I'm working with yields, it's already like normalized to pretty much like a -1-to-1 scale, or whatever you want to call it. It's kind of normalized. It's not exactly normalized because it's assuming that the population mean is 0 on these yields, and that might not be the case. And I'm too tired to really think that out. Like, what do I mean by population yield? But it's the yield of that variable. So it's not really how they all interplay with each other, but the housing yield does, and some of those variables do interplay with each other. So I'm sure the yields are not 0. I'm sorry, the means are not 0. So yeah, it's quote-unquote normalized, but it's not mean 0 normalized. It's probably something more like studentized deleted residual. Like assumed mean 0. I'm sorry, assume. It's probably assumed that the mean is 0, but it's not. Kind of like a studentized deleted residual is what I'm getting at. So anyway, because it was already kind of normalized around that 0 variable, I was able to easily classify it. Is it above 0 or is it below 0? And so I was able to do follow-up classification methods using the prediction outputted predicted Y response values. And then I was able to measure the mean of the mismeasures and then capture the error rates. And the error rate, the smallest error rate was best linear. So I was able to retrofit the model best linear for classification, and it beat the regular classification method. So I don't know if I'm not doing it. I don't know if I'm doing it right, but I'm just reporting the numbers. Didn't have time to troubleshoot it. I was just happy enough that the code worked. I know that I spent most of the time on the ETL and doing regression. Yeah, so moving on. This is the best model. Notice I grabbed a correlation matrix of just the best model. There was 42 factors. It was too cluttered. I didn't really want to show a bunch of variables that weren't related to each other anyway. But this kind of stresses like some variables are kind of like collinear with each other, like New York housing price and motor vehicle loans, and then motor vehicle loans, and then the total housing price, total housing sales, or whatever. But this one's important. TB3MS and DTB3. Those are like 3-month treasury yields. They shouldn't be in the model together. And in fact, I'm going to talk about that next slide, because I'm pretty sure that's why I'm seeing stuff like this. You know, this little curve here. It's probably because this here, this 16 and this -14 for population, they're probably inverted. And they probably have similar VIFs And so one VIF is the the coefficient's negative of the other one, so then it's doing this kind of stuff. But then, the model assumption still, I mean, this is the best model. I bet the model would do better if I took those factors out. That's what's kind of frustrating, because I think when I was first doing this on dry runs, I was doing it in SPSS. And in SPSS, it would automatically remove those. It would automatically flag VIFs over a certain number. But, there's still other good inferences. I like the regression tree model. It doesn't mess around with that BS stuff. What I mean by BS stuff is you probably won't see like population in here and then pop THM. You'll probably just see one. You probably won't see collinear variables. But you'll notice that quarters almost always in all my formulas come up in something, especially in the regression trees. So if you look at it, it's saying that if it's, quarter one, there's like a 9% chance that it's going to go up. Yeah, exactly. These are all the percent chances of the bottom. I believe these all add up to 100% left to right. And so, anyway, I didn't really spend that much time in that because my model wasn't that model, thankfully. So I don't really have to interpret that result. Moving on. These are the values that were pulled, and I wanted to share them with you because I thought that you might find them useful. But this is the power of what I built. It's kind of like a feature extractor. It's a feature extractor. That's the cool thing. But I did more than that. I built cross-validation, but I just didn't get it working in time. I knew it was going to be more effort than it was worth, and I was behind on this reporting. As you can painfully see with me recording it on my phone. But yeah, like some of the most interesting ones would be like motor vehicle loans. All transactions, and that housing is somewhat related to New York as well as San Diego, because that kept popping up. I don't know if San Diego was in this one, but it was in another one that I saw. Moving on. Example output. Future direction. Principal component analysis. That would take care of collinear variables. Seasonal trends. I would like to take care of it's great. I didn't know that quarters, affected housing price. But now that it makes sense, but now that I do, I would like to, reduce that effect and just really focus on the other variables. But I don't know if I need to. If I quantify it in quarters, I'm still capturing it in the other variables, aren't I? Like, if I smooth out the quarters, am I not excluding I don't know. A little confused. I haven't done time series adjustments, like moving averages or anything. So, anyway, but yeah, that was just a future direction because there is like a heartbeat effect to the return. I had a graph of it earlier, but I don't really care to show it. I don't have it right now to show it, but there was like a heartbeat graph, and it was quarter 3 and quarter 4 went in the same direction in one direction, and then quarter 1 and quarter 2 was kind of flat, but quarter 1 went in the opposite direction, about half the strength. I don't remember. I don't want to misquote it, but there is a pattern, and it's like every year it's the same pattern. I think that's it. I think that's the whole project. The goal was to find a model. Oh yeah, I needed to interpret the results. So the linear regression, the best linear regression was the backwards model, even with the collinear terms, and its error rate was 0.005. So I believe, if I'm interpreting this right, that is kind of like a standardized error rate. Root mean square error. Actually, no, I don't even think it's standardized. I think it's just the residuals squared and then the square root of that taken. And if that's the case, then it's supposed to be kind of like a measure of the actual yields. And if it's a measure of the actual yield, then I'm saying that that model's error is like less than 0.5%, which is pretty good, I would say. Less than 0.5% for one standard error on a model for a housing price for in between quarters. So that's how I believe that's interpreted. I might have bastardized it in some way. Please dock me if I did. And that's it. That's my housing model. I'm at 20 minutes and 26 seconds. So let me just show you some of these other things that I was talking about. I did a lot of work on this. A lot of work that you didn't see. But then I had like CV models. CV pics. This is the direction I was going. This was just me testing one of the models of the CV pics. The normality of it. And it was just awesome. And then that was like the outputs of my CV windows. It looks kind of blurry there. Let me just zoom in. You see those? It was showing me like the N of the CV, how many passes there were. So I had all that before. I had it. But then I realized I was like spending too much fun doing what I wanted. And then I even took some concepts from the book and like went from the minimum +1 standard error and then grabbed those models, and I wasn't sure like which one to pick, and that's why the book didn't recommend it, because you need to pick minimum N, I would guess, because you're trying to get a parse model. And it's so true too, because like the parser models would have like lower ends. Look at that, 5. So that was like one of the housing models. And CV models are way sexier because you get like tons of models. Everybody wants tons of models, right? I mean, because with like a housing with a regression model, it's just like you get one model, you know. And with best subsets, it's just like, I guess it's like the same thing like Mallow CP or something. They're all kind of like graded against each other, so you just pick the one that's got like a better grade that's closer to the other ones. But yeah, I don't know. There's just something about cross-validation that I really enjoyed. So I set all this up too. If you're interested, you could look at the GitHub code. And again, I apologize. Please forgive me for being so tired. I've been working on this for a very long time. And now my presentation has concluded. I wanted to do it by myself because I knew if I did it with the group, it would have been subpar. And if I would have done it with a group, I wouldn't have been able to do as much as I wouldn't have been able to do as much as I've gotten done going solo. I didn't have to ask. I just did. I went in my own direction. I took studious notes. Like, there's pages of notes on that. But yeah, that's it. Thank you, Dr. Kong. I really enjoyed this class. I learned a lot.